Hello and welcome to NASA's Johnson Space Center in Houston, Texas. I'm Joseph Zakrzewski, where today we'll be discussing the upcoming spacewalk scheduled for January 16th and January 23rd, U.S. Spacewalk 91 and U.S. Spacewalk 92. This will be the 273rd and 274th spacewalk in support of space station assembly, maintenance, and upgrades, and both you can see right here on NASA Plus. Today we'll discuss the programmatic and operations significance of these spacewalks. And then joining us today to discuss these operations are Bill Spetch, Operations Integration Manager of the International Space Station, and Flight Director Nicole McElroy. We'll start today's discussion with some initial remarks from Bill and Nicole, and then open it up for a Q&A session for our media members and those using the hashtag AskNASA on social media. To kick things off, we'll turn it over to Mr. Spetch.
All right, thank you very much. Well, Happy New Year, everyone. Happy 2025. This year marks a huge milestone in space station operations. In November, we will celebrate 25 years of continuous human presence on board the space station. Thank you for being here today as we discuss the next series of spacewalks outside the ISS. We are targeting 2 spacewalks for station maintenance right now on January 16th and January 23rd. Nicole will share more details about the specific tasks of each spacewalk. The first spacewalk on January 16th will be conducted by NASA astronauts Nick Hague and Sonny Williams. This will be the 273rd spacewalk in support of space station upgrades, maintenance, and assembly. This will be the 4th spacewalk for Nick and the 8th for Sonny. The second spacewalk will be the 274th spacewalk, and that will be conducted by Sonny Williams and Butch Wilmore. Now, after the spacewalk last year with Mike Barrett and Tracy Dyson, the team determined the cause of the water in the airlock was a service and cooling umbilical external to the spacesuit. The crew replaced that umbilical and have retested the full system in a pressurized configuration, and all tests of the suits and the umbilical have performed as expected. So as we kick off the new year, which will mark 25 years of humans continuously living and working on space station with these spacewalks, let's look ahead at the next few months in the space station operations. In February, we will have the undocking of Progress 89, followed by the launch of Progress 91. Then in March, we will have NG-21 released from the nadir port of Unity. Following that, we will look ahead to our next crew rotation with the Crew 10 launch and Crew 9 return shortly after that. And we'll move right on into a Soyuz rotation in April. So as you can tell, things aren't slowing down on space station. I want to thank the entire team and all those who have worked to support the upcoming spacewalks. This is a lot of effort that goes into every one of these things. And our team has supported really in an exceptional manner, especially for these particular spacewalks, getting all of the work done ahead of the holidays and through the holidays, getting ready to go here as we come up next week. With that, I'll turn it over to Nicole to talk through the rest of the details.
Thanks, Bill. So my name is Nicole McElroy. I'm the lead flight director for the first of the 2 spacewalks, so US EVA 91. As we said, we're planning for 2 spacewalks right now, so back-to-back, such that the crew is studying for both, getting their systems and suits ready to go, and then we'll be able to do on back-to-back weeks. As Bill mentioned, for US EVA 91, EV1 will be Nick, which means he'll be wearing the red stripes. EV2 will be Sonny in the unmarked suit, and they're both ready and looking forward to going out the door next week. While they're outside the space station, Butch and Don will be helping them from inside the space station during getting their suits on and off, as well as anything that they may need for comm support while they're outside. We also have a large team supporting this on the ground. This is just a small portion of the team that's been preparing here in Houston and around the world to get ready for the spacewalks next week, and we're looking forward to being on console together to support the day of next Thursday as well. All right, so getting into the tasks for US Spacewalk 91, we have 4 main tasks. The first is to remove and replace the RGA, or the Rate Gyro Assembly number 2. The second task is to remove and replace the planar reflector on the Harmony Module Zenith docking adapter. The third task is to install some patches on NICER, which is the Neutron Star Interior Composition Explorer. And then the fourth task is to prepare our alpha magnetic spectrometer AMS patch panel for future upgrade EVAs. We now have a short video to show these tasks, where the work sites are on the ISS, as well as the sequencing throughout the EVA. This is the planned tasks for the RGA and reflector EVA. EV1 exits the airlock first, wearing red stripes, and EV2 exits second, wearing white stripes. The first task in this EVA is to remove and replace RGA2 in the S0 truss location. EV1 will be working on the back side of the truss. They will carry the new RGA to the worksite, remove the bolts and connectors, and then pull the old RGA out. EV2 will be positioned inside the truss to assist with removing the electrical connections and the bolts. They will then put the new RGA in place. Once the RGA R&R is complete, EV2 will move to the Node 2 Zenith docking port to remove and replace the planar reflector. EV2 will remove 3 bolts in order to remove the planar reflector. They will then put the new one in its place and bolt it back down. Before leaving the worksite, EV2 will take photos of the new reflector and its surrounding area. Meanwhile, EV1 will be working on the nicer payload located on the S3 outboard truss. EV1 will be installing wedge-shaped patches from the caddy to cover the damaged areas of the light detectors. Once complete, they will then take photos to confirm the configuration is correct. EV1 will then move to the AMS worksite to move a C2V2 cable to allow access to the payload. Once both crew members meet up at the AMS worksite, EV1 will ingress the truss to access the AMS patch panel and then remove the cloth covering. EV1 will then do fit checks to determine what connectors are easily accessible for future upgrades. Once complete with their tasks, both crew members will then go back to the airlock and ingress, marking the end of the RGA and reflector EVA. So now that we've seen that overview, we're going to talk just a little bit more about the details of each of those tasks. So as we said, the first task is to R&R, remove and replace RGA2. This is our top priority task for this EVA because the RGA is the rate gyro assembly, which measures the rate of angular motion of the ISS, and RGA2 is currently showing some signs of degradation. So the task on this EVA is to go out and replace it such that we have a good and healthy RGA in place. The second priority task is to do the planar reflector R&R. The planar reflector is located on the International Docking Adapter and is used as an optical reflector target during visiting vehicle approach. The reflector on this location has shown that it's got some contamination on it, which reduces its reflectivity and therefore its effectivity when docking vehicles are approaching. The task on this EVA is to remove and replace that whole reflector such that then we have a good one in place. I actually have a demonstration here. This is what the reflector looks like. There's a glass piece in the middle which does the reflecting, and that is the part that's currently contaminated. So we'll be going out and removing these 3 bolts and then removing this whole piece, putting in another one that looks the same, and then fastening the 3 bolts down. The third task is then to install the patchers on that NICER payload. NICER is an X-ray telescope that studies neutron stars, black holes, and other phenomena. The telescope has light filters over the detectors, and one of those light filters have been damaged, which is allowing sunlight into the detectors and preventing them from being able to do operations during daylight. During this EVA, we will be installing patches such that we prevent that unwanted sunlight from getting in. So this is a mock-up of what that NICER looks like. It's got multiple of these circles located, and the light detectors are behind here, behind the light filters that you see kind of shown in the silver. So we'll be installing patches like this. The crew will be using a tool, not their finger, but it will be a patch that then can slide into one of the slots, which will prevent the unwanted sunlight from getting to those damaged regions of the shields, but still allow the rest of the detector to work as expected. There are about 7 patches that we currently plan to install during the EVA. And then the final task on this EVA is to prepare AMS for future upgrade EVAs. AMS will be going through upgrades, including getting a new radiator for increased cooling and then also increasing their capabilities. So this EVA will be preparations for those upgrades in the future. We will be moving a C2V2 cable out of the way such that the crew is able to fully get into the worksite, and then we'll be testing access to different connectors which may need to be replaced or changed out as part of those upgrade EVAs, and what we learn on this EVA will then inform the actual upgrades that will come in the future. So that's the summary for Spacewalk 91. As previously mentioned, we'll then transition into Spacewalk 92, which is currently scheduled for January 23rd. For the Spacewalk 92, EV1 will be Sunny, so she'll be wearing the red stripes, and EV2 will be Butch in the unmarked suit. Similarly, we have a large ground team that has been working to get this RFG Retrieval 2.5 EVA ready to go for quite a while, so I want to thank them for all of their hard work and dedication as well. We will now transition into a video that will show the details of what these tasks are, but at a high level, we'll be removing the radio frequency group, then collecting samples of the microorganisms, and then lastly, preparing the robotic arm elbow joint for a future replacement if needed.
This is the content for US EVA RFG Retrieve 2.5. EV1 in red stripes egresses first with a crew lock bag followed by EV2 in white stripes. Both crew work to release several quarter-turn fasteners on the multi-layer insulation tent over the radio frequency group. EV1 moves underneath the platform to remove the covering. Then EV1 visually inspects the radio frequency group and relocates the tool bag. Meanwhile, EV2 takes a portable foot restraint and installs it onto the robotic arm. EV2 ingresses the foot restraint and the arm moves to the next worksite. The crew will work together to remove rubber applied to the bolts on the aft wedge clamps. Then, using a ratchet wrench and a specially designed wrench, they will release the tension in the 5 clamps keeping the radio frequency group onto the stanchion. EV2 will return to the forward face of the stowage platform, then release 4 structural bolts using the pistol grip tool. Next, EV2 will slide the radio frequency group from the mounting plate. Then the arm will fly EV2 over to the airlock. EV2 will reorient the radio frequency group, and the 2 crew will stow it inside the airlock. EV1 puts the microorganism handle and caddy on their mini workstation. Then EV1 translates under the US laboratory to the vacuum exhaust systems vent. The first sample will be in open space, and the second will be a swab of the vent surface. EV1 will then translate to the laboratory's carbon dioxide vent to sample that location. Next, EV1 will return to the airlock to swab samples at various locations around the airlock hatch. While EV1 performs the microorganism sampling, EV2 will go to the zenith or top side of the external stowage platform. EV2 will remove the multi-layer insulation covering a spare robotic arm joint. EV2 will release 3 of 6 fasteners using the pistol grip tool. Then EV2 will drive the joint's motor approximately 6 degrees. This prepares the joint if it's needed on a subsequent contingency EVA. After recovering the joint, EV2 takes the crew lock bag back to the airlock, where EV2 will replace some tethers in the bag.
So to talk a little bit more about the details of the RFG Retrieval 2.5 EVA, as the name implies, the top priority is to remove the RFG and return it to the ground for refurbishment. The RFG is the radio frequency group, which is an S-band antenna, and was previously unable to be relieved from the stanchion mounting plate during US EVA 86. This time, we will be using a unique wrench tool to release the compressive force on the wedge clamps, which will release the hardware and allow it to be removed. Once removed, the RFG will be put into the airlock and then come back to Earth for refurbishment on the ground. The second task is to collect microorganism samples. The goal of this task is to swab external locations on the ISS in order to determine the presence of microbial life surviving at vacuum. Specifically, we're checking locations where microbes from inside the ISS could have been deposited on external surfaces, like near vents in the airlock, and then we're looking to see if that life could have survived in the vacuum of space. Finally, this EVA will prepare the spare robotic arm elbow joint for a future potential R&R if it's needed by removing some of the launch fasteners and setting the joint angle. Overall, the road to, or our preparations for all of these EVAs, has been going well. The crew on board has been studying their procedures and getting familiar with all of the tasks and are really excited and looking forward to going out the door, as well as the teams on the ground have been doing their last preparations, making sure that everything's ready to go. And we are also very excited for the spacewalks coming up over the next couple of weeks. With that, I'll hand it back to you.
Thank you very much, Bill, and thank you very much, Nicole, for joining us and talking us through all the details of the upcoming EVAs that are coming up here in the next couple of weeks, scheduled for, again, Thursday, January 16th and Thursday, January 23rd, and you can follow along on NASA Plus. We'll transition on to our question and answer session, and then for those media members that are watching online or watching through NASA Plus, if you wish to join the conversation, please press *1 to join the phone bridge. If you find that your question has already been answered or wish to retract that question, please use *2. And we'll start with the phone bridge, and Gina Sanferi with ABC News.
Thank you. We know they're both two experienced spacewalkers, but were they able to do any training while on the space station, virtual reality, or how do you train for a spacewalk when you're in space, but you weren't able necessarily to train for it in the NBL? Or is the NBL training enough that they can do this without that specific training?
Yeah, that's a great question. And so something we've been talking about a lot. A lot of what you mentioned, the NBL training or the Neutral Buoyancy Lab, is where the astronauts learn how to do the basics of spacewalk and do a lot of task training. So they get familiar with lots of different types of tasks, such that if something comes up on board that they need to do that they haven't necessarily seen before, they have that familiarity with the general task types. That being said, they have been doing a fair amount of training on board as well to get familiar with these sequence of events. We give them all of the procedures well ahead of time, so they'll have studied the actual procedures. And then they do also have a essential model of the ISS, and they can walk through all of the different steps that will be going on while watching a video similar to the one that we just saw, but in a lot slower detail, and goes step by step through each of the different handrails, the different translation paths, as well as then each of the different tasks that they'll be doing. One of the last things that they really do to get familiar with the hardware, so we talked through some of the hardware here, and similarly that new wrench, as well as the location and how big the RFG is. So they'll actually prepare by touching and manipulating the hardware that they'll be taking outside with them. So for example, they've seen the nicer patches ahead of time and are able to practice using those while inside, such that they know how they'll behave while they're outside as well.
Thank you very much for the question. And for those following on social media and NASA Plus, we invited you to join our conversation as well using the hashtag AskNASA. And this question comes from Instagram. Aaron wants to know, how do all these materials and tools that the astronauts use get up to the crew?
You know, it's a great question. As with everything that we fly up, we have to plan ahead. And we fly these materials and tools and everything that we need on the various cargo missions that come to and from the space station. So these tools, some of these tools have been on board for quite a while. Some of them arrived more recently on various cargo missions that we've had. So we fly them up from the ground, and that's how they get to station and get ready to go out. So we have a lot of forward planning to get them on board when we need them.
Thank you very much for your question on social media. And back to the phone bridge for Ryan Catton with NASAspaceflight.com.
Hi, thanks very much. I'm curious with the suits specifically, because we've seen over the last few years they appear to be becoming a little bit unreliable. So I'm just wondering how eager NASA is for an updated fleet of suits, shall I say. Is that something that you're interested in? Is that something that you would like to see? Thanks.
Well, clearly we have to maintain the suits. We've had them in our fleet for a long time. They do get periodic maintenance on the ground, and we fly them down, take care of them, fly them back up. They get maintenance on board, and so we're confident in the suits that we have on board, obviously, to continue to perform. There has also been work being done on new exploration suits, and there is some applicability with that to ISS down the road if and when those suits become available to us.
Thank you very much for your question. Turn it to Robert Perlman with Collect Space.
Thank you. Sort of working off that last question, the last two U.S. spacewalks were stymied by spacesuit issues. Have you added any additional steps in the preparation for these EVAs to double check on suit fit or on cables, or are there any additional steps or precautions you're taking to sort of avoid running into that same thing? And then, if I may, a specific question about EVA 92. What is it about the elbow joint on the Cat Arm 2 that is causing concern that it might need a replacement?
Okay, so to answer your first question first, the suits overall, and as a result of the EVAs we attempted last June, we actually just completed some suit fit checks yesterday for the crew. So they got into the suit, got fully suited up, and taken to pressure, and then were able to practice using some of the hardware and make sure that they would be ready to go out the door. So we've confirmed that their suit fit is very good and that they'll be ready for next week. And then as we're continuing to work with these suits, as Bill mentioned, right, there's a lot of data that we're watching on the suits in real time, both on the ground and what the crew can see on their heads-up display. So they are also able to have all of that information live and make sure that everything looks good. Going to your second question about the elbow joint, nothing specifically that we're tracking that's a problem with it. We're really just, if we ever needed to go out and replace it, this would be a joint that we'd want to replace very quickly because we use the robotic arm so often. And so we're getting it prepared such that it would be in a better configuration if we ever needed that EVA to go and do the full replacement of the joint. So this just gets it in the position of the joint in the angle that we would want in order to complete that R&R.
Thank you very much for that question. Going back to our phone bridge, Mark Carroll with Aviation Week Space Technology.
Yes, thanks. I would like you, if you could, to just kind of review how you addressed the umbilical coolant leak in the airlock from the last spacewalk attempt.
Sure. First step was to replace the hardware itself, right? We had an issue with that particular umbilical, so we changed it out with a new one, and we tested it in the suit. The team has also updated procedures for if it were to occur again to improve upon our response from the last time. The crew did an awesome job responding to that water during that EVA. We've taken, as we always do, we try to learn from everything that happens on board, and we've added a few things. We didn't have to add very much because most of the things that the crew had already been trained to do were absolutely right. We added a towel into the airlock to help with water if it does leak, but otherwise we've basically R&R'd the faulty hardware, and we've done an investigation, and we have a really good idea of what caused it.
Thank you very much for your question, and we'll go back to social media using the hashtag AskNASA if you wish to participate in today's conversation. Maddie on Instagram asks, how do you ensure astronaut safety during a spacewalk?
Yeah, that's a great question. So a lot of what we've been talking about is how do these suits work and how do we know that they're healthy? And so really what we're doing throughout the preparation for a spacewalk and then throughout the whole thing is making sure that all of the parameters on the suit where we're understanding the pressures and the temperatures of each of the different subsystems are within bounds and within bounds of what we expect and what we need them to be to keep the hardware safe. In the unlikely event that we did have a concerning event, we do have quick response procedures, some that the crew and the ground teams have memorized and some that they have available to them throughout the course of the EVA on their cuff checklist, which they actually wear on their arms, so we could respond to any of those concerning data measures. And again, I said before, but they've got the display in front of them, which allows them to have a heads-up display view of various parameters, and then we get a lot more data that we can see on the ground and be able to voice up to them if we're seeing something that's trending in an unexpected manner.
Thank you very much for that question and submitting on social media. And our final question is a follow-up from Gina Sunferry with ABC News.
But the leak issues you've been seeing in the Russian segment, how is the investigation of that proceeding?
The investigation continues. We're working very closely with our partners at Roscosmos to continue to look at the potential causes of the leaks, as well as identifying their locations within that small transfer tunnel. These are very small cracks that show up. They're very hard to see. In fact, you really can't see them with the naked eye. It takes a microscope a lot of times to go find where these things are. And so the teams continue to work very closely together with ground testing and through the operations that our Roscosmos colleagues are doing on orbit.
Thank you very much for that question. And that is all the questions that we have for today. A big thank you to Bill Spetch and Nicole McElroy for joining us to discuss the upcoming spacewalks that will be occurring outside the International Space Station. And thank you for tuning in on NASA Plus. You can tune in on NASA Plus for all the coverage around these spacewalks again on Thursday, January 16th and Thursday, January 23rd, pardon me. U.S. Spacewalk 91 is scheduled to begin at approximately 7 a.m. Eastern Time and last about 6.5 hours, and NASA Plus coverage will begin at around 5:30 a.m. Eastern Time. Thank you for joining us from NASA's Johnson Space Center.